For homework, I asked you to finish this problem to find the quotient of 6 minus 7i over 1 minus 2i. Recall that to find the quotient with complex numbers isn't actually division. It's a process of multiplication where we try to get the denominator to look like a real number so that the numerator can take on the complex piece. In order to solve this then, we need to take our original value of 6 minus 7i divided by 1 minus 2i and then multiply this both in the numerator and denominator by the complex conjugate of the denominator. The point behind doing this is because when we multiply by a complex conjugate, it ends up giving us a real number value. Now we need to FOIL to get rid of the values of I in the denominator and then to figure out what the complex piece will be in the numerator. 6 times 1 gives us 6. 6 times plus 2i gives us plus 12i. Negative 7i times 1 gives us minus 7i. And negative 7i times 2i gives us minus 14i squared. In the denominator, we get 1 times 1 is 1. 1 times positive 2i is positive 2i. Negative 2i times positive 1 is minus 2i. And negative 2i times positive 2i gives us minus 4i squared. Simplifying this, we end up getting this piece with the minus 14i squared is equal to positive 14. Recall that I squared is negative 1, and then negative 1 times negative 14 gives us positive 14. So 6 plus 14 will give us 20, and 12i minus 7i will give us plus 5i. In the denominator, we've got a minus 4i squared, which will simplify to be plus 4. Then plus 1 and plus 4 gives us 5, where the plus 2i and minus 2i end up canceling each other out. We can simplify this just a little bit more, recognizing that 5 can divide into both 20 and 5. 20 divided by 5 is going to give us 4. And 5i divided by 5 is going to give us I. So our final solution to this will be 4 plus I.